10th class acids, bases and salts అనే చాప్టర్ నుంచి in this video we are going to discuss what are acids, what are bases and what are the indicators that help identify whether a given substance is an acid or a base. ఈ వీడియో చివరి వరకు చూడండి సో దట్ యూ అండర్స్టాండ్ ద కాన్సెప్ట్ వెల్. ఓకే, when we say acids మనకి ఫస్ట్ గుర్తొచ్చేది ఏంటి? లెమన్ జ్యూస్, రైట్? లెమన్ జ్యూస్ ఈజ్ acidic in nature. We know that acids are sour in taste. Almost all acids are, in general, they are sour in taste. We use various acids in our daily life. For example, we use lemon juice that has got citric acid. We use tamarind that has got tartaric acid. We use curd that has got lactic acid. Not only these three acids. In our daily life, we use many other acids also. Please note this. Acids react with bases and various other substances. This is important topic. In this chapter, we are going to discuss what happens when acids react with bases and what happens when acids react with various other substances. This is one of the important topics of this chapter. But in this video, we are not going to cover that. In the following videos, we are going to cover. And acids అనగానే మనకి ఇంతకుముందు నేర్చుకుంది ఇంకొకటి ఏంటి? Acids turn blue litmus to red. Acids, they turn blue litmus to red. ఇవన్నీ కరెక్టే. బట్ కెమిస్ట్రీ పాయింట్ ఆఫ్ వ్యూలో మోర్ ఫండమెంటల్ డెఫినేషన్ ఆఫ్ యాసిడ్స్ ఈజ్ ద ఫాలోయింగ్. యాసిడ్స్ ఆర్ ద కాంపౌండ్స్ that release hydrogen ions when dissolved in water. For example, you take HCl. This is acid, right? Hydrochloric acid. When you pour this in water, when you make solution of HCl in water, this is called dilute hydrochloric acid, right? So what it gives is many hydrogen ions. H plus ions are called hydrogen ions. The substances that release hydrogen ions when dissolved in water are called, please note this. For example, hydrochloric acid, HCl, is one of the acids we regularly use. Sulfuric acid, that is H2SO4. Acidic acid, that is CH3COOH, and many more. These are the examples of acids. You have nitric acid, you have phosphoric acid, right? Like that, you have many more acids. Got it? When we talk of bases, the first thing that comes to our mind is soap. Soap water and soap, these are examples of bases, right? We know that bases are often bitter in taste and slippery in feel, right? We use various bases in our daily life. For example, we use calcium hydroxide, that is also called slake lime or milk of lime, to adjust pH of a given substance. For example, you want to adjust pH of soil, you use calcium hydroxide solution. Sodium hydroxide is one of the bases that is used in soap making. Magnesium hydroxide is used in antacid preparation. If somebody is having a problem with acidity, then we give antacid as the medicine, right? So antacids typically contain bases. For example, magnesium hydroxide is used as one of the components of antacid. Understood? We know that bases react with acids and various other substances. In this chapter, we are going to discuss what kind of reactions the bases will have with acids and various other substances. And bases anagane, we also learned that they turn red litmus to blue. Red litmus paper ganaka base liquid lo, for example NaOH, sodium hydroxide liquid lo ganaka dip chaste, it turns the red litmus to blue color, right? This is all fine. The fundamental definition of bases is the following. The bases are the compounds that release hydroxide ions when dissolved in water. Hydroxyl ions అని కూడా అంటాం, hydroxide ions కూడా అనొచ్చు, that is OH minus, right? For example, you have NaOH, sodium hydroxide, right? When you dissolve this in water, it dissociates to form Na plus and OH minus. The compounds that release hydroxide ions when dissolved in water are called bases. So that's why NaOH is a base. Potassium hydroxide, KOH, that also gives you OH minus. Magnesium hydroxide is also going to give you OH minus ions. That's why all these are bases. So to give you some examples of bases, sodium hydroxide, that is NaOH, calcium hydroxide, CaOH twice, and potassium hydroxide, KOH. These are few examples of bases. You will have many more bases. We'll be discussing some of them in our following videos. Okay? Now the question is how to identify whether a given substance is an acid or a base. మనకి యాసిడ్స్ ఆర్ సార్ ఇన్ టేస్ట్ అండ్ బేసెస్ ఆర్ బిటర్ ఇన్ టేస్ట్ అని తెలుసు, రైట్? సో వీ కెన్ యూజ్ టేస్ట్ యాజ్ ద మెథడ్ టు ఐడెంటిఫై, బట్ దట్స్ నాట్ ఎ వైజ్ చాయిస్. ఎందుకంటారా? ఫర్ ఎగ్జాంపుల్, ఇఫ్ యూ టేస్ట్ హైడ్రోక్లోరిక్ యాసిడ్, that can burn your tongue. So for safety reasons, never try to taste a material and say whether it is a acid or base. So better way is to use indicators. With the help of indicators, we can identify whether a given substance is an acid or base. So these are the substances. Indicators are some substances that help you identify whether a given substance or the given material is an acid or base. Okay? There are different kind of indicators. Naturally occurring indicators are there. There are some synthetic indicators, meaning these are man-made materials that are used to indicate whether a given substance is an acid or base. And the third one is olfactory indicators. Let's discuss one by one. The first one is natural indicators. Natural indicators are obtained from natural substances. For example, you may derive these from plant derivatives or something like that, right? So natural indicators change their color with the solution they are interacting. For example, certain indicators will have certain color in acid and they change the color when they interact with bases. So change in their color indicates whether the given substance is acid or base. These are the natural indicators. Natural indicators change their color to show whether a given substance is an acid or a base. These are made from extracts of plants and plant derivatives. Please note this. Generally plants నుంచి plant derivatives నుంచి extract చేసి ఉంటాం. వీటిని natural indicators అంటాం. For example, we know red cabbage, right? Red cabbage antam, but this is in purple. Other cabbage is in light green color, right? So red cabbage extract is one of the natural indicators. If you extract red cabbage liquid from the red cabbage, for example, దీన్ని క్రషర్లో వేసి లేకపోతే మిక్సర్ గ్రైండర్లో వేసి you mix it, you grind it such that you get some paste, right? This is one. And extract some juice out of that paste. That is extract of the red cabbage, right? It is generally in purple color. ఎందుకంటే క్యాబేజ్ పర్పుల్ కలర్లో ఉంది కదా, అది కూడా జనరల్గా పర్పుల్ కలర్లోనే ఉంటుంది. బట్ ఇఫ్ యూ pour this liquid into an acid, then the acid color turns into red, meaning the total solution color changes to red. జనరల్గా పర్పుల్ కలర్లో ఉంది కదా. Let's say you have red cabbage extract, red cabbage juice in a beaker. ఓకే, ఫ్యూ ఎంఎల్ ఆఫ్ యాసిడ్ని అందులో మీరు వేయండి. వేస్తే ఏమవుతుంది, ద కలర్ ఆఫ్ దిస్ లిక్విడ్ టర్న్స్ టు రెడ్ in the presence of acid. If you use base, then the color of the cabbage extract is going to turn to green. Please note this. Original ga purple color lo undi liquid. Okay, when you use this as an indicator, మన దగ్గర let's say we have an acid here, HCl. ఇందులో you pour some amount of this purple color liquid. What happens? All of a sudden this whole thing will become red in color. You have a base, dilute base NaOH. Okay, అందులో ఈ రెడ్ క్యాబేజ్ ఎక్స్ట్రాక్ట్ లిక్విడ్ కొంచెం పోర్ చేశారనుకోండి, దెన్ దిస్ పర్పుల్ కలర్ స్లోలీ టర్న్స్ టు గ్రీన్. అర్థమైందా? సో ఇట్ ఈస్ గోయింగ్ టు గివ్ యూ అన్ ఇండికేషన్. ఫర్ ఎగ్జాంపుల్, ఏదైనా ఒక సొల్యూషన్ ఉంది, అన్నోన్ సొల్యూషన్, యూ పోర్ దిస్ లిక్విడ్ ఇన్ టు దాట్. ఇఫ్ ఇట్ టర్న్స్ రెడ్, then you say that it is an acid. If it turns green, then you say that this is a base. Got it? Another natural indicator you can think of is hibiscus. Extract of hibiscus. It is generally in red color. ఇది కూడా రెడ్ కలర్లో ఉంటుంది. When you pour this liquid into acid, this becomes more highlighted red or strong red, అంటే డార్క్ రెడ్లా అవుతుంది. When you pour this liquid into a base solution, it turns dark green. Please note this. For example, I have CaOH twice, slake lime ఉంది కదా, అది మన దగ్గర ఒక బీకర్లో ఉంది. Now I have taken hibiscus liquid, extract of hibiscus, pour it into this. ఇనిషియల్గా రెడ్ కలర్లో ఉంది కదా, బట్ వీ నో దట్ CaOH twice is base. ఫర్ దట్ రీజన్ దిస్ హోల్ థింగ్, CaOH twice ఇనిషియల్గా మిల్క్ కలర్లో ఉంటుంది, రైట్, వైట్ కలర్లో, మిల్క్ ఆఫ్ లైమ్ అంటాం కదా, మిల్క్ కలర్లో ఉంటుంది. బట్ దెన్ వెన్ యూ పోర్ దిస్ రెడ్ కలర్ లిక్విడ్ ఇన్ టు దిస్, ద హోల్ థింగ్ టర్న్స్ టు డార్క్ గ్రీన్. దట్స్ వై యూ కెన్ సే దట్ CaOH twice is a base. ఓకే, అండ్ యాసిడ్ సొల్యూషన్లో పోసామనుకోండి, it will be still in red, but sometimes it is in dark red. Got it? So this is also a natural indicator. The third one we can think of is extract of turmeric or turmeric. Okay, generally it is yellow in color, right? So acids though it has no interaction. For example, even if you mix some amount of HCl plus this turmeric, okay, the color is not going to change. It will still retain its yellow color. But ala kakanda, you have, let's say, CaOH twice. Let's say you have a cloth, on that you have poured some amount of CaOH twice. Tarvata టర్మరిక్ని యూ స్ప్రింకిల్ ఆన్ దట్. టర్మరిక్ జనరల్గా ఎల్లో కలర్లో ఉంటుంది కదా, బట్ CaOH twice ఏదైతే ఉందో దానిలో డిప్ చేసిన క్లాత్ మీద వెన్ యూ పోర్ ఆర్ స్ప్రింకిల్ లిటిల్ బిట్ ఆఫ్ టర్మరిక్, దాట్ టర్న్స్ టు రెడ్ కలర్ ఆర్ రెడిష్ బ్రౌన్ కలర్. అంటే ఆరెంజ్ కలర్ నుంచి స్టార్ట్ అయ్యి ఇట్ కెన్ బికమ్ డార్క్ రెడిష్ బ్రౌన్. ఓకే, so it means, let's say you have taken turmeric powder and you have some substance, unknown substance. ఆ unknown substance మీద వెట్గా ఉన్నప్పుడు you know drop some turmeric powder on that. If it changes color, you can say that that unknown substance is a base. ఆ కలర్ చేంజ్ ఎలా ఉంటుంది, రెడ్ కలర్కి చేంజ్ అవుతుంది. కలర్ చేంజ్ ఏమీ లేదు అంటే కనుక యూ కెన్ సే దట్ that substance, the unknown substance, is an acid. Got it? And the other interesting thing is litmus papers. Litmus papers are made from a mixture of dyes extracted from plants called lichens. You see, this is lichens plant. The plant extracts low, you have a lot of dyes. Okay, certain dyes can give you blue litmus paper and certain can give you red litmus paper. Litmus paper and we have two kinds of litmus papers, red litmus and blue litmus. These are precise indicators. Actually, compared to other indicators, actually, these are better and widely used. For example, blue litmus paper అనేది తీసుకున్నారనుకోండి. You dip this blue litmus paper in an acidic solution, then the blue litmus paper becomes red in color. Blue litmus paper turns to red when it is in touch with acid. The same blue litmus paper, when you dip it in a base solution, the blue color remains as is. Please note this. Blue litmus paper base తో ఉన్నప్పుడు blue లోనే ఉంటుంది. You look at this. Blue, base and blue all have got B. Blue litmus paper remains blue in base. ఒకసారి అది తెలిసిపోయిందంటే, if you remember that, you can say that in acid, blue litmus paper turns red. Okay, now red litmus paper తీసుకోండి. Red litmus paper, when you dip it in a base, it turns to blue. Red litmus paper turns to blue when it is dipped in base solution. When it is in contact with acid, the red litmus paper remains red. మీరు గుర్తుపెట్టుకోండి, యాసిడ్ అనగానే డేంజర్, ఇట్ ఈస్ రెడ్ ఇన్ కలర్. డేంజర్ అనగానే రెడ్ కలర్తో చూపిస్తాం మనం, రైట్? రెడ్. రెడ్ లిట్మస్ రిమైన్స్ రెడ్ ఇన్ యాసిడ్ that is pictorially represented using red color. అర్థమైందా? BBB, that is blue litmus will be in blue when it is in touch with base. Red litmus, when it is in touch with acid, it is in red color. Got it? Please note all this so that it will be of use. The second type of indicators are synthetic indicators, right? Synthetic indicators అంటే these are man-made indicators. ఇంతకుముందు natural indicators ఏంటి? We have obtained them by extracting certain dyes and things like that from naturally occurring substances, plants and plant derivatives, right? అలా కాకుండా synthetic indicators అనేవి, these are the compounds that are made in lab. Okay? The purpose is to exhibit color change with the nature of solution. Synthetic indicators are the chemical compounds that are designed to exhibit color change with the nature of solution. Already natural indicators kuda alage kada, color change avutundi. Danni batti we are able to figure out whether a given substance is an acid or base, right? Similarly, in the case of synthetic indicators also, we make chemical compounds that exhibit color change with the nature of solution. For example, methyl orange is one of the synthetic indicators. Okay, methyl orange అనేది lab లో తయారు చేస్తారు. You can buy them and these are generally used. మనం naturally indicators మాట్లాడాం కదా, those are not really used in labs. స్టడీ పర్పస్ స్టూడెంట్స్కి సబ్జెక్ట్ ఇంట్రడ్యూస్ చేయడం పాయింట్ ఆఫ్ వ్యూలో దే ఆర్ స్టడీడ్. బట్ జనరల్గా ల్యాబ్లో వెన్ యూ ఆర్ డూయింగ్ కెమిస్ట్రీ ఎక్స్పెరిమెంట్స్, వాట్ యూ టిపికలీ యూజ్ ఆర్ సింథటిక్ ఇండికేటర్స్. ఓకే, మిథైల్ ఆరెంజ్ ఈజ్ వన్ సచ్ ఇండికేటర్. ఓకే, లెట్స్ సే ఐ హ్యావ్ HCl solution, dilute HCl ఉంది, acid. Okay, now if I pour some amount of methyl orange into this, all of a sudden this whole solution turns to red. Okay, so methyl orange turns to red in acidic conditions and it turns to yellow in base conditions. For example, I have NaOH solution. Okay, I'm pouring this methyl orange indicator. Few drops of methyl orange indicator ni add చేసాం అనుకోండి NaOH కి. Then this whole solution turns to yellow color. Okay, now we can use this indicator to identify ఇక్కడ HCl అనగానే యాసిడ్ అని తెలుసు, NaOH అంటే బేస్ అని తెలుసు. అలా కాకుండా we have some unknown solution. అది యాసిడా బేసా తెలియదు. Then you can use methyl orange indicator. Few drops of methyl orange indicator ఎప్పుడైతే ఆ సొల్యూషన్లో వేసామో అన్నోన్ సొల్యూషన్లో, if it turns to red, then you say that it is acid. If it turns to yellow, you can say that that is a base, right? There is another indicator that is widely used, that is called phenolphthalein. Phenolphthalein is colorless in acidic solutions. మీరు HCl, dilute HCl యాసిడ్ని ఒక బేకర్లో తీసుకుని drop few drops of phenolphthalein into it. The color is not going to change. Okay, if the solution color is not changing, then you say that this is acid. If the solution color changes to pink, light pink avachchu, dark pink avachchu, then you say that the solution is base. Advainda, when you have HCl and add some drops of phenolphthalein, then the solution has no color or colorless. If I have NaOH solution and if I add little bit of phenolphthalein to it, then the whole solution turns to pink. Please note this. Okay, these are also color based indicators. They show different colors in different kind of medium. Acidic medium one color, base medium in another color, right? That's how they can help you identify whether a given substance is an acid or base. Okay, the third class of indicators are called olfactory indicators. మనం ఇంతకుముందు చూస్తే నేచురల్ అండ్ సింథటిక్ ఇండికేటర్స్ అనేవి దే ఆర్ చేంజింగ్ దేర్ కలర్ టు షో వెదర్ గివెన్ సబ్స్టెన్స్ ఈజ్ అన్ యాసిడ్ ఆర్ బేస్, రైట్? ఆల్ఫాక్టరీ ఇండికేటర్స్ ఏంటంటే దే చేంజ్ స్మెల్. Olfactory indicators are smell based indicators. Smell of these indicators changes with the nature of the solution. For example, let's say you have onions. Extract of onions is one of the olfactory indicators. మీకు ఆనియన్ అనగానే ఘాట్ స్మెల్ వస్తుంది, రైట్? So this can be used as smell based indicator. When you use this onion extract as an indicator, when you mix that with some acid, the smell is not going to change. You still get the same onion like smell. Okay, dilute hydrochloric acid on మన దగ్గర, you have some onion extract, some liquid extract చేసాం, ఆనియన్స్ నుంచి కొంత జ్యూస్ లా చేసాం, ఆనియన్ జ్యూస్. Now onion juice has some smell. Now I am going to mix some amount of onion juice into the dilute hydrochloric acid, and later I'll smell. The smell is going to be as is. The onion juice is going to retain its normal smell in acid. But if you add the same onion juice to a base, NaOH solution on మన దగ్గర, దానికి యాడ్ చేసాం అనుకోండి, what happens is the onion juice loses its smell to become odorless. Okay, for example, I have NaOH, some amount of NaOH is there, and I'm pouring onion juice. Onion juice smell ala untudo manaku telusu, but you keep this for some time, okay, and then smell this, smell the liquid in this beaker. You don't get any smell, right? It means if I use onion juice and use it as an indicator to identify a unknown substance, whether it is an acid or base, then what I have to do, I have to smell, right? So I can add some amount of onion juice to the given unknown substance and see whether smell changes or not. Smell as is undanukondi, you can say that unknown substance is an acid. Ala kakunda smell with time taggipoyi it becomes odorless, then you can say that the unknown substance is a base. Got it? That's how it is used, but these are not as accurate. Okay, the next one you can think of is clove oil. Clove అనగానే మీకు తెలుసు కదా, the picture shows clove. Extract of this is called clove oil. Clove oil also can be used as an olfactory indicator. The reason is that it also has got some smell, right? Clove has some intense smell, right? Now when I add this clove oil to some acid, the smell is going to be as is. The smell is not going to change, meaning the clove oil is going to retain its normal smell in acid, whereas in base it loses its smell. Okay, clove oil few drops కనుక ఒక బేస్ లిక్విడ్లో వేస్తే కొద్దిసేపటి తర్వాత ఆ సొల్యూషన్ నుంచి మీకు క్లోవ్ ఆయిల్ స్మెల్ రాదు. వై దిస్ ఈస్ హ్యాపెనింగ్ అంటే క్లోవ్ ఆయిల్ ఈజ్ ఎసిడిక్ ఇన్ నేచర్. సేమ్ ఆనియన్ జ్యూస్ కూడా, ఆనియన్ జ్యూస్ ఈజ్ ఎసిడిక్ ఇన్ నేచర్, అండ్ వెన్ యూ యాడ్ దట్ టు a base, slowly some reactions happen because acids react with bases, right? Some reactions happen and eventually the smelling compounds, whatever మనకి స్మెల్ ఇస్తున్నాయి ఇంత ముందు, they may change their chemical formula, chemical nature, right? For that reason they lose their smell. అర్థమైందా? The next one we can think of is vanilla essence. Okay, vanilla extract ఉంటుంది కదా, that can also be used as an olfactory indicator. సేమ్ ఇంత ముందు చూసినట్లానే యాసిడ్లో ఇట్ రిటైన్స్ ఇట్ స్మెల్. మీకు వెనిలా స్మెల్ తెలిస్తే ఇట్ ఈస్ వెరీ ఇంట్రెస్టింగ్ స్మెల్, రైట్? సో ఇట్ రిటైన్స్ దాట్ ఇంట్రెస్టింగ్ స్మెల్ వెన్ ఇట్ ఈస్ మిక్స్డ్ విత్ యాసిడ్. అదే వెన్ యూ మిక్స్ దాట్ విత్ బేస్ ఇట్ ఈస్ గోయింగ్ టు లూజ్ ఇట్ స్మెల్. అర్థమైందా? మనం చూసిన 3 ఆల్ఫాక్టరీ ఇండికేటర్స్ కూడా యాసిడ్లో దే ఆర్ మెయింటైనింగ్ దేర్ స్మెల్ యాజ్ ఈజ్. బేస్తో మిక్స్ అయినప్పుడు దే ఆర్ లూజింగ్ దేర్ స్మెల్. Please note this. We have discussed that blue litmus paper and red litmus paper are generally used as indicators to identify a given substance is an acid or base, right? So easy. If you have these litmus papers, bunch of papers, you can test whatever the materials you want, right? Similarly, in the labs, we use methyl orange and phenolphthalein to identify whether a given substance is an acid or a base, right? For example, I have hydrochloric acid. Okay, hydrochloric acid ni మీరు బేకర్లో తీసుకున్నారు, dilute hydrochloric acid. Okay, then let's say that I have red litmus paper with me. I dip it in. Red litmus paper ni dip చేస్తే, since it is an acid, it retains its color as is, right? So hydrochloric acid, and when you dip this red litmus paper, the red litmus paper is going to retain its color, meaning it remains in red, right? So I have blue litmus paper. When I dip that into hydrochloric acid, what happens to it? It turns to red in acid. It means blue litmus paper is going to turn to red. Now I have the same hydrochloric acid. I want to use methyl orange as an indicator. Methyl orange turns to red in acidic conditions. It means the solution now is going to be in red color. Note this. Now I have, let's say, phenolphthalein as an indicator. The same hydrochloric acid I am using, right? Colorless in acidic solutions. It means when I add few drops of phenolphthalein to HCl, the color of HCl is not going to change. It is going to be as is. Phenolphthalein is colorless in acids, right? This is not going to happen with HCl. It is going to be the same with all acids. For example, if you take H2SO4, the same behavior. Red litmus in red, blue litmus turning to red, and methyl orange turning to red, and phenolphthalein is colorless, right? So acidic acid, nitric acid, and any other acid you take, the behavior is same. Okay, now let's look at NaOH. I have sodium hydroxide solution. It is a base, we know. right? So if I start with red litmus paper turns to blue in base, right? So anyway, solution లో if I dip red litmus paper అనేది స్లోగా బ్లూ కలర్కి చేంజ్ అవుతుంది. ప్లీజ్ నోట్ దిస్. And if I have blue litmus paper as the indicator, then it remains in blue. It is not going to change its color, right? Blue litmus paper remains in blue in base liquid, right? If I use methyl orange as the indicator, then the NaBH solution is going to turn to yellow, right? Methyl orange is going to turn to yellow. It means the whole solution color turns towards yellow, right? If I use phenolphthalein as the indicator, then the whole solution should turn to pink, right? Phenolphthalein turns pink means the whole solution NaBH plus phenolphthalein together is going to turn to pink. This kind of behavior is expected with all bases. For example, potassium hydroxide, magnesium hydroxide, calcium hydroxide, ammonium hydroxide, and any other base you take, the observed behavior is going to be more or less same. Red litmus paper is going to turn to blue, and blue litmus paper remains in blue, and methyl orange is going to turn to yellow, and phenolphthalein is going to turn to pink. Understood?